Hi guys, question 13. We've got quite information to make sure we fully understand before we can answer this question. Now, it's a rectangular car park and the length x. Okay, so normally, this is my sketch of a rectangle. We call this dimension here the length. And it says the length x, okay, so that has to be x, is to be 5 meters more than the breadth. Okay, so this it's got to be 5 more than this, so that means whatever x is, I've got to take away 5 and I'll get this breadth or this width. So the perimeter of the car park has to be greater than 32, so form an inequality. Okay, so if we add all these x's, we're going to have 4x, and collect all these negative 5's, we're going to have minus 10, and that has to be more than 32. Okay, so that's part A done. So formed an inequality. Now, for part B, it says the area of the car park has to be less than 104. So for part B, the area, so that's going to be this times this, so we've got x being multiplied by x minus 5, has to be less than 104. Okay, so I've formed an inequality. Now, part C, it says solve them and determine a possible set of values for x. So that means the perimeter has got to be more than 32 and the area has got to be less than 104. Okay, so let's go ahead and solve this. So we've got 42 there, divide by 4. So I know this isn't in the 4 times table, but halving it and halving it again is pretty easy. So I'm going to get 10.5 there. So x can be any value more than 10.5. Let's expand this. So x squared minus 5x is less than 104. We need to bring everything over to one side because it's a quadratic. So x squared minus 5x minus 104 is less than 0. Now, this one immediately is posing a slight issue because it's not a very nice number to find factors of. Completing the square I could do, but this is a 5. Now, let's just have a little think. Right, so I'm going to just do some really sneaky maths here. So if I half this one and double this one, I get another factor. Half this one, double this one, half this one, double this one, and I can see I've got a factor pair with a difference of 5. Okay, I was worried there for a second, but this is going to be fine. So let's put a 13 there and an 8 there. How do I make this negative 5? Well, it's got to be negative 13 plus an 8. And I get critical values of 13 and minus 8. Now, with any quadratic inequality, you must make a sketch. So I'm just going to pause the video quickly and make a sketch. Okay, so it's doesn't need to be a work of art. The scale isn't important. We've just got a minus 8 root and a 13 root. And here we're looking at less than 0. So in all the previous videos I've done this, so I'm going to keep doing this. So the function of x is equal to 0 here. When we put it equal to 0, we get the roots. So where it's less than 0 is below this line, below the x-axis. So we're looking for in here. So the values must be less than 13 and they must be greater than minus 8. Okay, so to finish off part C, we have to say the set of values for x. Now we've got some criteria here. So our numbers that we're going to be dealing with are minus 8, 10.5, and that's from down here in part A, and 13. So our last answer we got, this bit in green here, told us it can be anywhere in here to satisfy the area problem. But to satisfy the perimeter problem, it had to be bigger than 10.5. So what we're looking for now is this overlap in here, which tells me the x value can be less than 13, but it has to be more than 10.5 to meet both inequalities. And there you have it.